The history of physics. Physics, the study of matter and energy, has a rich and varied history dating back thousands of years. From the early Greek philosophers to the breakthroughs of 20th-century scientists, physics has continuously evolved and expanded our understanding of the natural world. In this article, we will explore the major developments in physics during different time periods, focusing in particular on the period around 1600. Ancient Greek physics, 600 BCE to 400 BCE. The origins of physics can be traced back to ancient Greece. The early Greek philosophers sought to explain the natural world using reason and logic rather than relying on religious or supernatural explanations. Thales, often considered the father of Western philosophy, believed that all matter originated from a single element, water. His contemporary, Anaximander, proposed that all matter originated from a single, boundless substance, known as the apeiron. The Greek philosopher Empedocles introduced the concept of the four elements, fire, earth, air, and water, which he believed to be the building blocks of all matter. These early ideas formed the foundation for later philosophical and scientific explorations in physics and laid the groundwork for more systematic investigations. Classical physics, 17th–18th centuries. The 17th and 18th centuries marked a significant shift in the study of physics. During this period, several scientists made groundbreaking discoveries and formed the basis of classical physics. Galileo Galilei, an Italian physicist and astronomer, is often considered the father of modern physics. His experiments in the field of mechanics challenged the prevailing theories of Aristotle. Galileo's most famous experiment was his study of free fall motion. By rolling balls of different masses down inclined planes, he observed that they would all reach the bottom at the same time, regardless of their weight. This contradicted the Aristotelian belief that heavier objects fall faster than lighter ones. Galileo's experiments laid the foundation for the later development of Newton's laws of motion. In the same period, Johannes Kepler, a German astronomer, made significant contributions to the field of optics and planetary motion. Kepler formulated three empirical laws that described the paths of planets in the solar system. His laws showed that planets move in elliptical orbits around the Sun, not in perfect circles as previously believed. Isaac Newton, a British physicist and mathematician, was another key figure in this era. His work laid the foundation for classical physics. Newton's laws of motion, published in his book, Principia Mathematica, explained how forces affect the motion of objects. He also developed the law of universal gravitation, which described the attraction between all objects in the universe. The rise of modern physics, 19th–20th centuries. By the 19th century, physics underwent significant transformations. The introduction of new mathematical tools, such as calculus, along with advancements in experimental techniques, paved the way for further exploration. James Clerk Maxwell, a Scottish physicist, made monumental contributions to the understanding of electromagnetism. Through his mathematical equations, known as Maxwell's equations, he unified the concepts of electricity, magnetism, and light into a single theoretical framework. His work demonstrated that light is an electromagnetic wave. Albert Einstein, a German physicist, revolutionized physics with his theory of relativity. In 1905, he published his special theory of relativity, which showed that the laws of physics hold true in all frames of reference moving at a constant velocity. His theory challenged Newton's laws of motion and introduced concepts such as time dilation and length contraction. Einstein's subsequent development of the general theory of relativity further explained gravity as the curvature of spacetime by massive objects. Quantum physics also emerged during this period. Max Planck, a German theoretical physicist, introduced the idea that energy is quantized and comes in discrete units called quanta. This concept laid the foundation for the development of quantum mechanics, a branch of physics that describes the behavior of particles on a subatomic level. Physicists such as Niels Bohr, Werner Heisenberg, and Erwin Schrödinger further developed quantum mechanics, leading to the formulation of the famous Schrödinger's equation. Conclusion: the history of physics is one of continuous advancement and discovery. From the early Greek philosophers to the groundbreaking theories of 17th-century scientists like Galileo and Newton, and the transformative insights of 19th and 20th century physicists like Maxwell, Einstein, and Planck, physics has expanded our understanding of the universe and reshaped our worldview. The period around 1600 witnessed the birth of classical physics and laid the foundation for modern physics, leading to the development of revolutionary theories that continue to shape our understanding of the natural world today.